Hi everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we are going to be learning some GCSE physics. Specifically, we're learning about gas motion and gas pressure. So if that does interest you, feel free to give the video a like if you do enjoy it. And also feel free to subscribe so you don't miss a video from me, but also so you can be a part of this amazing community here on YouTube. I also do have an Instagram and a TikTok. Everything is at the GCSE science teacher. So feel free to check those channels out as well if you do want more GCSE content, not just for physics, but also for chemistry and biology as well. So let's talk about today's video. Like I said, we're talking about gas motion and gas pressure. Let's recap about the particle model of gases. We've talked about this at length, but you should be able to recognize that gases move around in a haphazard fashion. They randomly flow over each other and they take up the volume of whatever container they're in. They don't really have a fixed volume. They don't really have a fixed shape. They will just spread and diffuse, which is why diffusion I've put as one of the points here, because in the case of diffusion, gases will move around. That's why if we were to spray a perfume on one side of the room, it would diffuse across the room from a high to low concentration. We'd be able to smell that perfume later on. Remember, like I said, those gas particles, they move at a constant random motion. And as they do this, they will collide with one another. So they'll bang into each other and rebound, or they'll bang into or collide with the container walls as well. They do also move faster than, say, solid or liquid particles. And this is because of the energy that these particles have. Remember, if we have a solid and we heat it up, turns into a liquid, we heat it up further, it turns into a gas. We've actually added thermal energy, essentially adding or increasing the internal energy that those particles in that substance have. And that's why as the temperature increases, the average kinetic energy of those particles or those molecules increase in a gas as well. So that's why they move at a faster rate. And this idea we're going to come on to in a bit more detail as we move throughout the video. So temperature and pressure are often linked together, and you may have actually seen in real life the effects of temperature and pressure. If you look at your deodorant, if it's a spray, have a look at the back of it and you actually see that it says to keep it out of hot climates or keep it out of the sun. And that's because inside that spray container, that aerosol container, there is lots of gases that are at increased pressure. If you increase the temperature, those gas particles will actually increase the pressure further, and it could actually cause an explosion. So it could be very dangerous, which is why those particular types of items need to be kept in a cool, dark place. So let's talk about the science of this. Increasing the temperature on a gas in a fixed volume, like in the aerosol can, will increase the pressure that's found there. But why is that? Well, it's because there's more kinetic energy that has been transferred through the thermal energy store. In the case of the temperature. So if you increase the temperature, you give the particles more energy to collide and move around more frequently. And these increased rates of collisions will actually increase the pressure exerted on the walls of that container, like the aerosol can. And you might be thinking, okay, well, how does that work? Well, pressure, if we look at the equation for pressure, pressure is equal to the force divided by the area. So if we have more collisions, you could argue that there'd be more force exerted on the walls of that container, like the aerosol can, in the same volume, in the same area. Remember, volume is the 3D version of a 2D shape. So the area is just the surface of that aerosol container, for example. So if you increase the forces that are applied to that area on the aerosol can, you increase the pressure as well. And that's why it could be quite dangerous if those aerosol cans get into a very, very high temperature. And that's why they have those warning labels on the back. Something also to be aware of when we talk about pressure, I always like to show these two images of shoes. If you look at a pair of heels and a pair of flippers that you may use when you go swimming, you can see that even if the same person wore those shoes, the pressure exerted would be slightly different. So if, for example, I was to wear the heels and stand on someone's foot, which would be really bad to do, but let's just imagine that's what we did, it would hurt a lot more than standing on someone's foot with the flippers on. And the reason is because the area is much smaller, but the force is the same. So I would have the same mass, I'd have the same force, or the same weight, I should say. Remember, mass and gravity working together gives us the weight in newtons, so the same force acting downwards. But because the heel has a smaller surface area, especially on the actual heel part, the actual pressure that is applied is going to be much, much greater because the area is much smaller, but the force is the same. Whereas the flippers, because you've got a larger surface area, and the force is the same, the pressure is going to be a lot less and it's going to hurt a lot less as well. So that's just something to put into context, that in this case with temperature and pressure, remember force and area are very much interlinked as well. So we now know that if we were to increase the temperature on a set of gas particles, we can actually increase the pressure. And that's because by increasing the temperature, we provide the particles with more energy. That thermal energy supports those particles to move more. So the kinetic energy of those particles increases. This causes an increase in the collisions, and there are therefore more collisions that occur by those particles, and therefore more collisions in a specific space will increase the pressure that's occurred. Remember, pressure, if we have more force in a given area, we have more pressure that is occurring. But let's say, for example, we were actually to increase the volume. So the volume is now not constant. We've increased the volume and we've kept the temperature the same. We can actually decrease the pressure quite easily because there's more space for those particles to collide, which means there's less frequent collisions with the walls of the container. The temperature is now constant, so the energy supplied to those particles is arguably less, so they're not going to move as much, and that means there's less frequent collisions and therefore the pressure decreases. Now, we can actually show this in an equation, which is actually called Boyle's law. This was a scientist that came up with this idea, and you do get this given in your equation sheet in the exam, and you do need to know how to use it and how to apply it, and I'll talk about that in a moment. The equation is PV equals a constant, and the P stands for pressure, which is in pascals. This is an SI unit for pressure. We have V, which is the volume in meters cubed, and a constant, which is just a constant number. Now, this is something, like I said, you get given in the equation sheet in the exam, but you also need to know how to apply it as well. So that's where we're going to come on to next. So here is the type of question you could get asked in the exam, and it's essentially to calculate the change in pressure. So we're using Boyle's law, but we're actually using it in a different form. So we have P1 V1 equals P2 V2. And this looks really confusing, especially with the subscript numbers that are underneath the letters there. But actually, this is not as confusing as it may appear. P1 is just the initial pressure. V1 is just the initial volume. And we're equaling this to the P2, which is the final pressure, and V2, which is the final volume. So we can actually use this equation and rearrange it to calculate whether it's the change in pressure, whether it's the volume, whether it's the change in volume there. Whatever the case is, we can actually rearrange this equation to calculate something we need to know. So I'm going to give you an example here. So a gas occupies a volume of 0.10 meters cubed at a pressure of 100 pascals. Calculate the pressure exerted by the gas if the gas is compressed to a volume of 0.45 meters cubed. Assume that the temperature and mass of the gas stay the same. Now, it's really important that the gas temperature stays the same, as does the mass, because those two variables can actually change the pressure overall. As we know, if we increase the temperature, we will increase the pressure as well. So the temperature must stay the same, and the mass, of course, needs to stay the same too. So what we first want to do with any equation, if you have one and you need to rearrange it, write out the original equation first. So P1 V1 equals P2 V2. We are working out the pressure, the new pressure, which is P2. And this equals P1 times V1, which we already have. And we have V2, which we've put on the other side. Because it's times by P2, we've just had to move it to the other side. So we've done the opposite of it. So that's why it's divided by V2. Then we put the numbers in. So P1 in the question is 100 pascals. We're timesing this by the initial pressure, which is 0.10 meters cubed. And we're dividing this by 0.45, which is the final volume as well. Really important that you check your units, because that will give you an indication of what numbers go where. Remember, pressure is in pascals and meters cubed is the volume. If you do get stuck in the exam, I would recommend you circle the key numbers in the question. That way you can actually identify what it is you're working out and what it is you don't know. Remember to also put brackets around your information at the top, because that way you can actually get a correct answer. Sometimes calculators can be a bit funny, so just double check with your brackets that you've placed this in there, and then you should get your answer of 2,222.5 0.2. And because this is in pascals, this is obviously the pressure as well. So don't forget to write your units. Don't forget to underline your answer, so it's really clear to the examiner what your answer is. So here is a question for yourself. It says a gas occupies a volume of 0.40 meters cubed at a pressure of 120 pascals. Calculate the pressure exerted by the gas if it is compressed to a volume of 0.35 meters cubed. Assume that the temperature and mass of the gas stays the same. Do comment down below. Show me your working out. Don't forget your units as well. I will leave the solution in the description box as always. So like I say, have a go at it. I'd love to hear from you. So for those of you who are doing triple science, you do need to know a little bit more in this topic, specifically the work done on a gas and how this affects gas pressure. So remember that work is the transfer of energy by a force. It's often measured in joules. And doing work on a gas increases the internal energy of that gas. And if you'd like to learn more about internal energy, I actually did a video on it recently, and I'll link it at the end of this video for you. But just in short, remember that if you do work on a gas, you increase the internal energy of that gas, meaning that there is an increase in the temperature of that gas as well. And this is because the temperature is a measure of the average kinetic energy. And if you increase the internal energy, you will actually also increase the temperature as well. And this kind of explains why different objects, say for example bicycle pumps, will actually get warm when they're used to inflate tires, because you are essentially increasing that internal energy and by default increasing the kinetic energy of those particles, which is a measure of the temperature as well. So that's how it all links together, and something worth mentioning at this point. Thank you so much for watching today. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, feel free to give it a like, share it with someone else, and please do subscribe so you don't miss any videos from me. It's great to have you as part of this community. I really do mean that. So thank you so much for all your support. If you would like any other videos, I do have some linked at the end of this one. I also have my Instagram and TikTok, like I said, where I post quite regularly key information and other bite-sized revisions. So if you are interested in anything to do with that, check those socials out. All of it is at the GCSE Science Teacher, and there are links in the bio on my YouTube channel too. In the meantime, have a fantastic day, and I will catch you in the next one. Take care. Bye.